Did you know the COVID-19 pandemic has left an indelible mark on humanity, claiming millions of lives and reshaping societies worldwide? But could it also have unlocked a profound secret about the nature of our reality? Dr. Melvin Vopson, a scientist studying SARS-CoV-2, the virus behind COVID-19, has proposed a startling theory. Our universe might be a simulation. Even more controversially, his research suggests that mutations in the virus, and perhaps all life, are not random, potentially challenging the foundations of the theory of evolution. While the simulation hypothesis has long been a topic of philosophical debate and science fiction, Vopson's work brings a scientific lens to the idea. By analyzing the behavior of the SARS-CoV-2 virus and applying principles from information physics, he argues that the universe exhibits patterns consistent with a simulated construct. Could the pandemic have inadvertently provided clues to one of humanity's most existential questions? The simulation hypothesis, a scientific perspective. The simulation hypothesis posits that our reality is not real in the traditional sense, but rather a highly advanced simulation created by an intelligent civilization. While this idea has often been dismissed as speculative, recent developments in information physics have given it new credibility. Dr. Vopson's research builds on the mass energy information equivalence principle, which suggests that information is a fundamental component of the universe, alongside mass and energy. In his study, Vopson explores the second law of infodynamics, a concept he introduced in 2022. This law states that information entropy, a measure of disorder in information systems, tends to decrease over time, contrary to the traditional second law of thermodynamics, which states that entropy always increases. Vopson argues that this behavior mirrors the optimization processes seen in computer programming, where data compression and efficiency are paramount. The second law of infodynamics appears to be manifesting universally and is, in fact, a cosmological necessity, Vopson writes. This points to the fact that the entire universe appears to be a simulated construct. By applying this principle to genetic information, atomic physics, and even cosmology, Vopson suggests that the universe operates like a highly efficient computational system, minimizing information content to reduce computational load, a hallmark of a simulated reality. SARS-CoV-2 mutations? A clue to non-random evolution? One of the most provocative aspects of Vopson's research is his analysis of SARS-CoV-2 mutations. The virus, which has undergone thousands of mutations since its emergence in December 2019, provided a unique opportunity to study genetic changes in real time. Vopson's findings challenged the conventional view that mutations are random, a cornerstone of the theory of evolution. After examining thousands of SARS-CoV-2 variants, Vopson discovered that 98.92% of mutations involved the deletion of nucleotides, while only 1.08% resulted in additions. This pattern, he argues, aligns with the second law of infodynamics, which seeks to minimize information content. In other words, the virus appears to optimize its genetic information over time, much like a computer program streamlining its code. This behavior is fully reminiscent of the rules deployed in programming languages and computer coding, Vopson notes. If the universe is a simulation, such optimization would be necessary to reduce computational power and data storage requirements. If mutations are not random but instead follow predictable patterns of information optimization, it could fundamentally alter our understanding of evolution. This raises profound questions. Is natural selection driven by randomness, or is it guided by underlying informational principles? And if the latter is true, what does that imply about the nature of life itself? The implications of a simulated universe. If Vopson's hypothesis is correct, the implications are staggering. A simulated universe would mean that everything we perceive, our bodies, the stars, even time itself, is part of an elaborate digital construct. This idea challenges not only our understanding of reality, but also our place within it. Vopson's work suggests that the universe's tendency to minimize information content is evidence of a built-in optimization mechanism akin to the algorithms used in computer simulations. This would explain phenomena such as mathematical symmetries, the efficiency of biological systems, and the apparent fine-tuning of physical constants. A super-complex universe like ours, if it were a simulation, would require a built-in data optimization and compression mechanism, Vopson explains. This is exactly what we are observing via empirical evidence all around us. However, Vopson is quick to acknowledge the limitations of his research. While the patterns he observes are intriguing, they do not yet constitute definitive proof of a simulated reality. The simulation hypothesis remains just that, a hypothesis. But as technology advances and our understanding of information physics deepens, it may become possible to test this idea more rigorously.